Hello, welcome to Chapter 8, Lesson 6. Today we're going to be talking about comparing and ordering fractions. So to compare fractions, we need to create equivalent fractions. Okay, the only way we can know if a fraction is greater than or less than is if we're comparing the same size. And that denominator, the bottom number, tells us how big of a piece we're talking about. With the same denominators or the same numerators, if we create equivalent numerators, then we can talk about, we're talking about the same number of slices, but they're different sizes. So that's kind of a little trickier, but doable for comparing fractions. And to do that, we need to use the least common multiple, or the least multiple common, okay, that's just a confusing way to say it. The smallest number that they share. So for example, if I wanted to compare, let's say 1/2 to 5/8. In order to compare them, right? Because this guy here, it's like a pizza cut in half. I'm going to eat one. And this guy here, I'm going to cut my pizza into 8ths, which drawing is not great, right? Because we're not going to be able to create equal pieces. But if I'm looking at 5/8, I'm comparing different sizes. So if I just do this, times 4 times 4, now I'm comparing 5/8 to 4/8, right? So it's just like if I cut my piece of pie into 8 equal pieces, I'm talking about 4 of them. So we can see if we're comparing both 8ths, we're talking the same size. This one I have 4 pieces, this one I have 5 pieces. So 5 is going to be greater. I'm going to eat it up. Okay? So that's just like a quick. Let's do some real examples here. So for example 1, it says Raymond has an insect collection. The table shows the lengths, how long, 4 insects in his collection. The lengths of 4, okay. Which is longer, a mosquito or a whirligig beetle? Okay, so we're trying to compare. Mosquitoes are 1/4 inch and a whirligig beetle is 3/8 inch. Okay, so this is a strategy you can use, right? You would say, where do 4 and 8 meet when we're talking multiples or counting by those numbers, right? So if I look at 4 and I count by 4, 8, 12, 16, and then I look at 8 and I count by 8s, 8, 16, 24, the smallest number that they have in common is 8. Okay? Now, if we look here at the whirligig beetle, it multiplied by 1/1. Now, we don't have to do that. Okay? That's just extra work. If we see 3/8 already has a denominator of 8, we do not have to multiply it by anything. Now 1/4 over here does not have a denominator of 8, so I need to multiply it by 2/2 because 4 times 2 is 8. Whatever I do to the denominator, I also need to do it to the numerator. So 1 times 2 is 2, 4 times 2 is 8. So now we're going to compare the fractions 2/8 and 3/8. Okay, so if I cut a pizza into 8 equal pieces, here I'm eating 3, here I'm eating 2, we know that 3 is going to be the larger number. So of the numbers 2 and 3, 3 is closer to 8. We could think of it that way. The fractions where the numerator and denominator get closer to each other, that means it's going to be greater than the ones that are farther away from each other. So a whirligig, that's kind of a fun word. WHIRLIGIG. A whirligig beetle is longer. All right. Example 2 here. Ready? So, oh my. The table shows the cooking times needed for different foods. Order the foods from least to greatest. That's a big mistake I see a lot of kids do, is they don't pay attention. Am I supposed to go greatest to least, least to greatest? So if we underline it, it will help our eyes draw back up to there so that we can see, hey, that's right, least to greatest. I should double check. Okay, so we're looking at 1/4, 5/6, and 2/3 hours. Okay, Now, if I'm going to look at, oh, this one they want us numerators. I don't know that I agree with them. I think I would like to do denominators because I see they all go into 12. But we'll work with them here. So I've got a 1 numerator, a 5 numerator, and a 2 numerator. So if I'm looking at 1, 5, and 2, and I do their multiples, their count by numbers. I do 1, 2, 3, 4, 5, 6, 7, 8, right? All the numbers. Multiples of 5s are 5, 10, 15. Multiples of 2 are 2, 4, 6, 8, 10, 12, and so on, right? So we notice that they all end, the first time they all have in common, first number they all have in common is 10. So the least common multiple of the numerators is 10. So that's the top numbers. Okay, so how can I get 1 to equal 10? I'd multiply it by 10, right? 10 40ths. 10 over 10. That's what I'm multiplying by. Now, if I want 5 to equal 10, I multiply it by 2. So I'd be comparing 10 twelfths. If I got 2 equal to 10, I'd multiply it by 5 over 5 to get 10 15ths. Okay, so when we compare the numerators, the fraction with the greatest denominator is the least fraction, right? Because that's the pieces that are cut the smallest. When the denominator is like 1 over 2, it means we're dealing with 2 pieces of our pizza. So those are huge pieces of pizza, right? But when I'm looking at the rice here, its denominator is 40. Imagine having a piece of pizza and you cut it into 40 pieces, right? You're dealing with really small pieces there. So we know that 10 40ths is going to be the smallest. And so 10 is much closer to 12 than it is to 40. So 10 out of 40 is smaller than 10 out of 12. Okay, but what about 10 out of 15? So that one is, right, I've got 15 pieces of pizza and I'm eating 10. Or I've got 12 pieces of pizza and I'm eating 10. As the numerator and denominator get closer, it means we're dealing with a larger fraction. Okay, so if we check, we could draw a quick model, 1/4, 2/3, 5/6. Okay, which is fine, but you know, models are so tricky, especially when we get into higher numbers like twelfths. They're hard to draw equal pieces. So I really like thinking about it in mathematical terms. I mean, it's good to look at models as well, but so from least to greatest, it would be 10 40ths, 10 15ths, and then 10 12ths. All right, here's our quick guided practice. I don't know, you guys. I always like getting the denominators the same because then we're just comparing the numerators, what's bigger, what's smaller. When we're comparing numerators, it just gets so tricky, right? Because then you got to think about it a little more. So I'm going to look at 4 and 2 here. I'm going to do the multiples of 4. 4, 8, 12, 16. Multiples of 2. 2, 4, oh, there we go. 4 is where they intersect. So if I multiply 2 by 2 because I want it to equal 4, I'd get 4 as my denominator. 1 times 2 is 2. So I'm comparing 3/4 to 2/4. So what one's bigger? 3/4 is, right? Okay, we could have easily done this one too, thinking about models, because we're only cutting it into 4 pieces versus 1/2. So this is half of a pizza. Here I'm eating more than a half of a pizza, right? 3 out of 4. So our models can help us to know as well. Now this one might be a little tricky. Oh, look. Our numerators are the same. So if we're comparing the distance of our numerators, this one's 3 away, this one's 1 away. These guys are closer together, so I know that 3/4 is the larger number. Okay, and if I look at the fraction 3/6, I notice I can simplify that. I can divide it by 3, divide it by 3, and get 1/2. Right, and we know again over here, we're comparing 1/2 to 3/4, so it's the same thing. Those little sneaky book writers trying to trick us. So I do have a couple more examples here. Now, here's what I think. I think it's not so bad. I'll do, just to show you how I want your work done. This page 522. Let's do one like, let's do this guy here. Ooh, this is going to be a little tricky. 8 and 10. Where do they intersect? Let's count by 8s because we can know 10s in our head, right? 10, 20, 30, 40. Let's count by 8s. 8, 16, 24, 32, 40. Okay, so 40, I know that that's a 10, so I know it's going to be 40. So here's what I'd like to see for work. What do I need to multiply 8 by to get 40? 5 times 5 times 5, so it'd be 20 over 40. Okay, what do I need to multiply 10 by to make it 40? Just 4. Multiply by 4, so I'd get 12 over 40. Okay, so now I'm comparing 20 40ths versus 12 40ths, and I know that 20 40ths is bigger, right? Because I mean 20 pieces instead of 12 pieces. So 20 40ths would be the bigger fraction. All right, I really want to do these guys down here because I just think that they're pretty tricky sometimes, and so I want to make sure that we're understanding. Like, let's do this guy here. So I've got 3, 4, and 6. I'm going to do multiples, okay? 3, 6, 9, 12, 15, 18, 4, 8, 12, 16, 20. 6 is 6, 12, look at this. 12, 12, 12. That's the first number where they're all the same. So I want to get all of my denominators to equal 12. Okay, so I'm going to do my work over here. This would be a great lesson to do work in your notebook. So how can I multiply 3? What can I multiply 3 by to get it to be 12? I could get 4 twelfths. 1/4, I have to multiply it by 3 over 3 to get 3 twelfths. And then 5 sixths, I have to multiply 6 by 2 to get 10 twelfths. Okay, so I'm going from least to greatest. So least is going to be 3 twelfths, but I need to write the original fraction down, 1/4. That's going to be 4 twelfths, so I have to write down the original fraction, 1/3. And then my greatest number is 5 sixths. Okay, you might be able to look at these and just tell me, hey, Mrs. Hamer, I know that one's the biggest, but I don't want that. I want proof. Okay, I want your work to show me that, yeah, this is why I know that one is the biggest and that 1/4 is the least. Okay, so make sure you're really careful with your work. That's all I have for you for today. Thanks for watching, and make sure you always ask a question if you have one.